Assalamu alaikum, sir. So my one-to-one topic presentation topic is training method and data augmentation of neural network in audio classification. My name is Munim bin Mukid. My ID is 20201228 and I'm from section 2. So what is neural network? Uh, a neural network is a series of algorithms that endeavors to recognize underlying relationship in a set of data through a process that mimics the way the human brain operates. In this sense, neural network refers to system of neurons, either organic or artificial in nature. As such, they tend to resemble the connection of neuron and synapses found in the brain. They are used in variety of application in financial services, from forecasting and marketing research to fraud detection and risk assessment and audio classification. It has three main components: input layer, hidden layer, and the output layer. And it has the ability to learn, is the ability to compute incomplete data, and it's a very powerful technique. Types of neural network. There are several types of neural network: convolutional neural network, recurrent neural network, feed-forward neural network, autoencoder neural network. The convolutional neural network contains five types of layer: input layer, convolution layer, pooling layer, fully connected layer, and output layer. Each layer has a specific purpose, like summarizing, encoding, or activating. Convolutional neural network have popularized image color classification and object detection. Recurrent neural network use sequential information such as timestamp data from a sensor device or a spoken sentence, composed for a sequential sequence of terms. Unlike traditional neural network, all input to a recurrent neural network are not independent of each other, and the output for each element depends on the computation of its preceding element. Feed-forward neural network, in which each perception in one layer is connected to every perception from the next layer. Information is fed forward from one layer to next layer in the forward direction only. There are no feedback loops. Autoencoder neural network are used to create abstractions called encoders are created from a given set of input. Although similar to more traditional neural network, autoencoders seek to model the input themselves, and therefore the method is considered unsupervised. So what is audio classification? Audio classification is the task of assigning a level or class to a given audio. It can be used for recognizing which command a user is giving or the emotion of a statement, as well as identifying a speaker. So training model, the model used for audio classification can be convolutional neural network (CNN) and a recurrent neural network (RNN), as RNN work for the sequential data. And we know that in audio classification, there are some sequential data. So that's why RNN can be used for audio classification too. The training method of CNN. There is a five layer: convolutional layer, pooling layer, fully connected layer, ReLU, and output layer. The convolutional layer is the core building block of CNN. It carries the main portion of the network computational load. This layer performs a dot product between two metrics, where one matrix is the set of learnable parameters, otherwise known as the kernel, and the other matrix is a restricted portion of the receptive field. The kernel is especially smaller than an image, but is more in depth. This means that if the image is composed of three RGB channels, the kernel height and width will be especially small, but height and width will be especially small, but the depth extends up to the all three channels. During the forward pass, the kernel slide across the height and width of the image, producing the image representation of the receptive region. This produce a two-dimensional representation of the image known as the activation map, that gives the response of the kernel at each spatial position of the image. The sliding size of the kernel is called stride. Pooling layer. The pooling layer replaces the output of the network at certain location by deriving a summary statistic of the nearby output. This helps to reducing the spatial size of the representation, which decrease in the required amount of computation and weight. The pooling operation is processed in every slice of the representation individually. There are several pooling functions, such as the average of the rectangular neighborhood, L2 norm of the rectangular neighborhood, and the weighted average based on the distance from the central pixel. However, the most popular process is max pooling, which is reports to the maximum output from the neighborhood. Fully connected layer. Neurons in this layer have fully connected with all the neurons in the preceding and the succeeding layer, as seen in regular fully connected neural network. This is why it can be computed as usual by the matrix multiplication forwarded by the bias effect. The fully connected layer helps to map the representation between the input and the output. Output layer is represent the output. ReLU, the rectified Lilian unit, has become very popular in the last few years. It it computes the activation is simply threshold at 0. In comparison to sigmoid and 10H, ReLU is more reliable and accelerate to convergences by 6 times. Unfortunately, a con is that ReLU can be fragile during training. And this is the image training method of CNN. Here you can see that there is a input layer, as a conversion layer, polling layer, ReLU, and fully connected layer, and at the center output layer is there. And this is another picture that actually shows how actually CNN works. Here cat and dog are the level photos, and then conversion layer, max pooling layer, and fully connected layer all are performed, and then the machine is detected that it is a cat. The data augmentation, in the case of natural neutral neural network. In the case of neural network, data augmentation simply means increasing size of the data, that is increasing the number of images present in the dataset. Some of the popular image augmentation techniques are flipping, translation, rotation, scaling, changing brightness, adding noise, etc. As we can see, using data augmentation, a lot of similar image can be generated. This helps in increasing the dataset size and thus reducing overfit. The reason is that as we add more data, the model is unable to overfit all the samples and is forced to generalize. So here we can say that there is a original image and the data and the augmented image are presented here in the slide. So data augmentation in CNN, there are several processes of data augmentation. Image resizing, image gathered from the internet will be varying size due to presence of fully connected layer in the most of the neural network. The image being fed to network will be required of a fixed size. Scaling, having different scaled object of interest in the image is the most important aspect of image diversity. When your network is in hand of real user, the object in the image can be tiny or large. uh, Translation, we would like our network to recognize the object present in any part of the image. Also, the object can be presented partially in the corner of the edge of the image. For this reason, we shift the object to various part of the image. This may also result in addition of a background noise. Rotation 90 degrees. The network has to recognize the object present in any orientation, assuming the image is square. Rotating the image at 90 degree will not add any background noise in the image. Flipping, this scenario is more important for network to remove biasness of assuming certain feature of the object is available in only a particular site. Lighting condition, this is very important type of diversity needed in the image dataset, not only for the network to learn properly the object of interest, but also to simulate the practical scenario of the images being taken by the user. The lighting condition of the image are varied by adding Gaussian noise in the image. So here are some images that so you can see that in the first picture, here is the lighting condition is used, and the second picture it is flipping, and the third one is rotating, and the fourth one is the translation. And here's some reference that where I took the information from. So thank you so much, sir.